Hi Sarah, Uncle Dave here with a couple of birthday treats for you. Let's say that, well, the first thing I'm going to show you is what I call a binary sort. We'll call it a Sarah sort. And the second thing I'm going to show you is a little trick with, or demonstration with some coins. A little puzzle. Okay, so let's say you've just successfully won a game of kings, and you've got two decks here. I've got black back and red back. And of course, if you're an engineer like you are, there's no way you're going to just approximately separate them into two piles and put them back in two boxes, right? An engineer is going to want to have them sorted properly into their original decks. And a physicist or anybody else really wouldn't understand that, but such as it is. Okay, so I can show you that I've got, black and red backs sufficiently shuffled, right? And so what I'm going to do is, because it's kind of hard to hold over 100 cards all at one time in one hand, I'm just going to break these into approximately equal packets. Okay, so here we've got our shuffled two decks together. So what you do is a binary sort. What you do is whatever color's on top, you just keep going and collect those. So we got red. Now you take those off. Now you're going to keep going and spreading cards until you get to the last of the next batch of reds. There it is. Now you switch to black, because black's on top. So we're going to push off the next batch of blacks. So we got black. Do that again. Black. Right there. Now we got to do reds. So we can do red. Collect all the reds. You keep going until you get another red, till the end of the next batch of reds. Red. Now we do black. There was only one of them. All until the last of the next batch of blacks. Black. Red. Red. Now we do black. Black. And then red. Okay, so what we've done is you can see we've sorted some of them. We got groups of red, blacks, there's reds, blacks, reds, black. So we have accomplished a partial sort. Now what we do is we keep going. We keep doing it again. So we got reds. Go to the end of the next batch of reds. Reds. Now we're going to do blacks twice. Black. And black. And then red. All right. Now let's see how we're doing. We've got reds, black. Yeah, they're sorted more. Okay, so that's two passes. Let's do another pass, see what happens. So we got blacks, or reds rather. So we got reds. We have to do red again. See, we're going through a lot of blacks now, till the last of the reds. There we go. Now, with any luck, that third pass has completely sorted the deck into two equal, or two colors. A binary sort. We got blacks on this side, reds on this side. So you can put those aside and pick up the other half of your shuffled king's deck and do it again. So you can see you can do this kind of fast. So we got black, black, red, red, black, black, red, red, black, black, red, red, black, black, red, red, black, black, red. All right, so we've got a partial sort there. That was one pass. Let's do it again. Red to the last one of the reds. Red. Now we're going to do black. Go to the last of the blacks, and then another black group right there. Now we're going to do red again. Red, red, black, black. Okay. We're still not quite done, so that's what, the second pass. Let's do a third pass. So we got red, red, black, and red. Okay, now it turns out we have red on the bottom, so we can just put those on the bottom. And I think we've got them sorted. There we go. Reds and blacks. Now you can pick up the first piles you did, sorted red and black, and there. Now you've got your cards sorted into two decks that are nicely done. The engineer would like. You can put them back in the boxes and wait for the next victims to play kings with you. I hope you see how that worked. Now I've got a little coin demonstration for you. So I call that the Sarah sort. Oh, I also wanted to show you that, what if you had a shuffle, just any shuffle deck? By the way, let me show you this. So we've got them sorted here now, right? This one's all red. This one's all red. And if you flip it over, of course, now we can look at it this way. We've got reds and blacks, right? But we can do a sort this way too if you want. So we got red, we got black, black, red, red, black, black, red, red, black, black, red, red, black, black, red, red, black. Okay, now let's do it again. Red, red, black, black, red, red. All right, that was the second pass. Let's do a third pass. Black, black, red. Now we've got them sorted, red to black this way. There you go. So you can do a binary sort, however you want. You can do evens, odds, face cards, non-face cards, black back, red back, whatever kind of binary sort you want. What if you wanted to reshuffle? I'll show you a good shuffle. By the way, I think it's possible to prove that at most you need 4 passes to do that, and the minimum you need is 3 passes. I haven't proved that, but maybe an engineer brain can figure that one out. Here's a good shuffle for you. Split the cards into about half. Turns out with practice you can actually get them exactly in half. Butt them together like this. You kind of work the corners. You kind of mesh them together like this, and you can get them interwoven. See? I don't know whether you can see that. It turns out that's called a Pharaoh shuffle. The cards are perfectly interwoven. And if you do that 8 times perfectly, you can restore the deck to the original order, which is kind of interesting. You just put the corners together and you wiggle them a little bit and they'll go together. See there? And if you don't have much else to do and you've spent a lot of time practicing, you can actually do this one hand. See if I can do that so the camera sees it. Separate them out into 2 packets. Oh, one-handed. So you do one-handed like this. Orient them together like that, see? That's kind of cool. There you go. Okay, so that's your card binary sort. Have fun with that. I call it the Sarah sort. Now let me show you something with 4 coins. I've got $50 here, easier to see, but you can use 4 quarters. What you're going to start out with a diamond shape, where 4 coins are touching each other in a diamond shape like this, right? It doesn't matter the orientation. So what I want you to do is go from the diamond shape to a linear shape. And here's the rules. Starting from the diamond shape, or you might want to call that a parallelogram, I guess. You cannot lift a coin off the paper, although it doesn't really matter. You move only 1 coin at a time. When you move it, it has to end up touching 2 other coins. Okay. with the object of getting the linear shape. You can do as many moves as you want, but you can only move one coin, and it has to end up touching two other coins. That's one move. Of course, now we've just created a different diamond shape. So I can take this one, put it over here. We've just created a different diamond shape. So you can see that that particular move doesn't accomplish anything. One thing you cannot do is that you cannot push a coin through two other ones like that, because you're moving two coins. So you can only move one coin at a time. So your goal is to figure out how to go from this shape, moving one coin at a time, such that it touches two other coins when you're done. Do that as many times as you need to end up with a linear shape. So that's your challenge. I did it in 5 moves, and I was shocked to discover that it's possible to do it in 4 moves. And then as an added fun thing, after you've done that, you might realize that it's possible to arrange, I don't know if you can see the numbers on these. I've numbered it 1, 2, 3, and 4. It's possible to have 24 different arrangements of 4 things, right? If the order of them matters. So my question is it possible that given your initial arrangement, say 1, 2, 3, 4, your diamond, is it possible to get all 24 arrangements? So for example, 1, 2, 3, 4, or you could get 1, 2, 4, 3. You could do 1, 3, 2, 4, or 1, 3, 4, 2, right? There's 24 of those arrangements. Is it possible to start from a given diamond shape and get all 24 of those arrangements? I think it is. I haven't proved it yet, but that's your challenge. Okay, so there's your little fun video for today. Happy birthday. I hope you have a good one. Go play Kings. Go do some math. Do some engineering and play with coins. Happy birthday from Dave and Chris in Salt Lake. Love you. Bye-bye.